Hi, I'm Madison.
I'm Laurence.
And today we're going to be talking about aromatic rings and one reaction they undergo.
Aromatic rings are very stable, which make them different from normal alkanes. We need very harsh conditions to make them react with just about anything.
So let's get learning. We'll be focusing on one reaction called halogenation, which falls under the category of electroaromatic substitution, otherwise known as EAS.
But wait, before we talk about halogenation, shouldn't we talk about the general pattern of EAS?
Oh yes. What we basically do for EAS is that we generate the electrophile, but please keep in mind that this part differs from one reaction to the next.
First thing we have to do is use one of the double bonds in the benzene ring to attack the electrophile.
Which breaks the aromaticity of the ring, right?
Yeah, exactly. So now that the benzene ring has attacked the electrophile, we have a cationic state in the ring.
Yep. So all you need to do now is reestablish aromaticity. Oh, you're right.
Remember, the base alters on what was left over from the electrophile.
So now we have this down, let's hurry and talk about halogenation. Halogenation can be done either with chlorine or
bromine.
Halogen electrophiles are formed when the dihalogen Cl2 or Br2 attacks on a iron trihalide, which could either be FBr3 or FeCl3. Then, with this electrophile, the aromatic ring attacks the outermost halogen atom.
Be aware though, it is impulsive to go right ahead and attack the middle halogen atom just because it has a positive charge. Because it has a full octet, it does not make sense for you to attack it. It makes more sense for you to attack the outside one and transfer the electrons.
Now, the following steps fall under the general EAS pattern.
And there you have it, our major product along with the catalyst, FeCl3, and the generated waste product, HCl.
Now, with the knowledge of electroaromatic substitution, let's see what CU knows about halogenation. Okay, so currently walking on campus trying to find out what department we should hit up to see if they know a lot about halogenation, so stay tuned. First stop, the College of Music.
All right, so I'm here with Brian. Brian is our music composition and economics major. And Brian, how much do you know about OChem?
Well, I feel like chem means chemistry, but I don't know about the O part.
So would you be able to tell us how you would get this molecule from this?
It's just like a chloride. Chlorine?
Yeah, it's a chlorine.
It's chlorine. Maybe a hydrogen bond or something with whatever this is. Are these carbons?
Yes.
Okay, okay. So it's a what?
It's an aromatic ring.
An aromatic aroma?
Depends.
Okay.
So as you can see, the double bond in the ring attacks the chlorine and kicks it off to make this an AlCl4 ion. There's then a positive charge on the benzene ring along with the newly added chlorine, and then the created ion from the first step will go in, take off the hydrogen, reform the double bond, and you are ended up with the product.
And so the adventure continues. Wonder where we're going. We're currently scooting through the physics help room. About to ask an open question.
Just to spice things up a bit, we're going to introduce how to attach another group to our benzene ring through a process called nitration. Alright, so here we are in the physics building with my good friend Brendan. Brendan here is a graduate student at the University of Colorado Boulder, and he's getting his PhD in physics. And today we are going to teach him how to attach a nitrate group onto a benzene ring through the process of nitration. So what is going to happen is this oxygen is going to go ahead and protonate this hydrogen right here, not protonate, attack this hydrogen right here, and then it's going to go ahead and kick off that group. To here, we're going to have the same thing. The oxygen is going to come here and attack the positive nitrogen, kick off the water. To show that water is being lost in the step. And this forms what is called a nitronium ion. What's going to happen is this benzene ring is going to come in, it's going to attack this nitrogen right here. Electrons are going to transfer over to the oxygen. This attaches the nitronium ion to our benzene ring, and water will come in, attack the hydrogen, come right here, and you have successfully attached nitrate group to a benzene ring.